Thank you very much, Simon.
Thank you very much, and thank you for inviting me to lead this first session. It's a real privilege to be involved in such an innovative idea. You know, these sort of seminars are not sort of commonplace, and it's really great to be part of exploring this paper together this morning. So, as was mentioned there, my name's Simon Cox. I lead the Blackpool Research School. I also work for the Education Endowment Foundation part-time as their mathematics content specialist, and I am based in a school, so half of my time is based in a secondary school in Blackpool, so I fully appreciate everything that's going on in all of your schools at the moment, and thank you very much for taking the time out this morning to join us. So we're going to talk this morning about our early maths paper, and this paper came out in January of this year, so it's relatively new. Obviously it came out just before the pandemic hit, so it got a bit of attention before we all went into lockdown. But before we explore the paper, I thought it might be useful just to mention a few things that we do at EEF and also in the Research School Network. So our work at EEF splits into three broad categories, the first of which is synthesis. This is where we look at existing evidence that's already out there. So there's been obviously research going on in education for years and years, and we pull that together. Some of it is UK-based evidence, some of it is international evidence, and our job really is to put that into a form that is more accessible and more useful for school leaders and for teachers. So I've worked in schools for going on for 20 years now. I fully understand that most of us do not have the time or the inclination sometimes to read in-depth research papers, some of which can be several hundred pages long. So part of EEF's role is to distill that into something that's a bit more usable. Most famously, I would say, is probably the Teaching and Learning Toolkit, and that came out in 2010. To support really the work that was done with the pupil premium. So the purpose of the toolkit was to direct pupil premium spending in an evidence-informed direction. One of the things that people don't always realise about EEF is that despite being famous for sort of research and things like that, we're an organisation with a real moral imperative, and that is to narrow the disadvantage gap. So the reason EEF was set up in 2010 was to narrow the disadvantage gap and to look at what research evidence says will help us in doing that. So that's the synthesis part of our work. We also generate new evidence. So where there are gaps in the existing evidence base, we commission trials into programmes or ways of teaching or things that schools can do. And we don't always know if these will work. And often we find that actually those things make little or no difference, sometimes even a negative difference, but that's just as useful to us as finding out that something does work, because part of our job is not just telling schools what is likely to make a difference, but also telling schools what is likely to not make a difference, because obviously if we're going to take on new things, we need to stop doing some old things as well. On the screen there at the moment are two of our maths focused trials, and they are particularly, well, one of them came out really positively. So First Class at Number, which is a 10-week numeracy intervention delivered by teaching assistants, we found had a big impact, and we labelled it as one of our promising projects as a result. And what I would say is if you are ever thinking about introducing some kind of an intervention into your school, not just maths, it could be on anything, just take a look at the EEF website and look at the promising projects, because those are things that have been through a research trial and have shown to make a difference. And then what we tend to do is scale those up. So once we've tried it with some schools, we try it with several hundred schools under everyday conditions and see if it still makes a difference. And one of our most recent successes in that regard is Nellie, the Nuffield Early Language Intervention, which even when we scaled up to hundreds of schools in everyday conditions, still had a significant impact on children's outcomes. So that's a good place to look if you are looking to introduce something in your schools. And then we mobilise the evidence. So this is part of what I'm doing now, and our job at EEF and also in the Research School Network is to share what we know about evidence with schools. We're always a bit cautious about this, so when we share evidence, we are never saying that this will definitely work and that you should all stop what you're doing and do this. That's not what we're about at all. We are just saying that according to the research that's been done and the evidence that's out there, these are the best bets. So if you're looking to improve mathematics in the early years in Key Stage 1, our guidance report is a good starting point. but it's not a sort of blueprint for great teaching. We're not saying just follow this and that, everything will be sorted. There will be things that you do that don't feature in the guidance reports, and that's absolutely fine, because there's lots of things that we do as teachers that aren't evidence informed, and that's okay. So we're not saying everything needs to be led by evidence, but it's a starting point for those best bets, things that have worked somewhere else and may well work in your context. So that's our work here at the EEF, and one of the reasons why we decided to commission the paper that we're going to look at this morning is based on what we know about early maths. So early maths is a really strong indicator of children's overall academic achievement, and perhaps surprisingly, or perhaps not, those children that grasp number early on go on to have success in all subjects right through to the age of 18 and beyond. So it's a really strong indicator of later academic success. So if we can get maths right early on, then we are more likely to narrow that disadvantage gap and get those children where they need to be later on. The other thing that we know from the evidence base is that once children fall behind, they are unlikely to catch up. We obviously put a lot of effort into seeing which interventions have an impact and which don't, but most of the interventions we trial at EEF don't have a significant impact. Some do, but most don't. It's really hard to get children to catch up once they are behind. So all the evidence points towards the fact that the best way to narrow the disadvantage gap is through high quality classroom teaching for all children. But we accept there will be other things that we need to do, but that should be our #1 focus in schools at all times. And in terms of the disadvantage gap, there's a graph there that's on the screen, that was from 2017. We know that it's there even when children begin early years, there is a gap. But what we do know is that it widens and widens over time until by the end of secondary school, the gap is very significant. It's going on for 2 years. We also know we did a report that came out probably about 2 months ago now into the impact of the pandemic on the disadvantage gap. And what we found in that is that it's looking very likely that any progress that we have made in narrowing the gap may have been undone by the partial school closures that we've had. Obviously, that was based on prior evidence, so it wasn't based on evidence from a pandemic, but it was based on evidence from school closures in other contexts. But obviously we're gathering evidence on that all the time as we move forward with the work that we are doing. So that's why we consider early maths to be really important. And so we commissioned the report, which we're going to look at this morning, came out in January of this year. And I just want to talk you through the timeline of how that came into being. So the reason I'm sharing this is really to put across the fact that this was a long process that we went to. So we first of all looked at the initial scope, and we decided when we were scoping it out, talking to academics, talking to teachers, we decided that we were going to make the report go across early years and Key Stage 1. Similar to the previous guidance report that we'd done in maths, which went across key stages 2 and 3. And the reason for that is we found that obviously there are pedagogical and curriculum differences between the early years and Key Stage 1, but actually the evidence around what works in improving maths was very similar for both in the way it was for Key Stages 2 and 3. And our experience of the Key Stage 2 and 3 report is that it got teachers working cross-phase together. And that was really impactful. And so that was another reason why we decided to make this one go across the early years and Key Stage 1, because there was real benefit in those practitioners working together. Step 2 was appointing our guidance panel, and then our evidence review in step 3. And so the evidence review was done externally. EEF don't conduct their own evidence reviews for these guidance reports. It goes out to tender, and that was won by a university team led by Jeremy Hodgen, and also involving Camilla Gilmore, who's an expert in mathematical cognition, and Victoria Sims. So they conducted the evidence review for us, and when that came back, and we've not published that yet, but we will publish it really soon, it's several hundred pages long. So it's a systematic evidence review, which means that they compile a list of search terms, and then they trawl the academic literature, and then they decide using set criteria which papers will go into the review and which papers won't. And the reason we do a systematic review is so that it can be replicated. So if anybody else wanted to do the same thing that we had done, they would be able to, using the criteria that we had set out, and also that it can be updated. So in 5-10 years time, we can use the same criteria again and update that evidence review. So it's all transparent and all out there exactly how we conducted this. Then came to the writing of the report, and this was led by Amy Clark at EEF with a team who worked on distilling the 200-page evidence review into a series of recommendations for teachers and leaders. And then we went out to consultation and writing training. We're actually doing that at the moment. So I'm leading a team of early years and Key Stage 1 specialists who are currently writing a training programme to go alongside this guidance report. So that was an 18-month process in total and is actually still continuing now. So it's not something that we write quickly. It is a long process that we go through. And so we came up with these 5 recommendations. Now, as I mentioned before, this is not intended to be a comprehensive guide to maths teaching and learning. We've just focused on particular areas where there was reasonably strong evidence that certain things can make a difference. I will be honest, and the evidence wasn't as strong for early years in Key Stage 1 as it was for Key Stages 2 and 3, but it was strong enough for us to put together a series of recommendations. So just running through those recommendations quickly, the first one is that we need to develop practitioners' understanding of how children learn mathematics. The second one is around dedicating time for children to learn mathematics and integrate mathematics throughout the day. The third one, interestingly, is the only one that features right through to Key Stage 3, use manipulatives and representations to develop understanding. When Colin Foster, who worked on the Key Stage 2 and 3 guidance report, talked about that when they were doing the evidence review, talked about wanting to find an equivalent to phonics for mathematics, so something that the evidence said was particularly strong. They didn't find anything quite as strong as for phonics, but he said manipulatives was the thing that came closest. So using manipulatives in the teaching and learning of mathematics is critical. Recommendation 4 was about ensuring that teaching builds on what children already know. Particularly challenging in the early years because obviously they all come with very different starting points. And recommendation 5 was about using high quality targeted support to help all children learn mathematics. And that's in common with all of our guidance reports. Number 5 really is what to do if numbers 1, 2, 3 and 4 haven't worked. So what do we do next for those children that need that additional bit of support? Now we can't focus in this morning on all 5, there's far too much there, so we're going to focus in on recommendation 2. And the reason I've chosen this one is these seminars have a literacy theme woven throughout, and recommendation 2 in the maths report is the one which features things like storybooks, discussion and vocabulary, so I felt it fit really nicely with the theme of these seminars. So before we split off into groups in just over 5 minutes and discuss some of the findings from the paper, I just want to share a few headlines really from this particular recommendation. So the first thing that we found is that it was really important, both in the early years and in Key Stage 1, to dedicate time in the day for what we called purposeful mathematical activity. So it's setting aside a period of time, whenever that happens to be, when we explicitly teach a mathematical concept. Now, we struggled with the concept explicit teaching. We decided to leave it in, but it's really important that we don't read that as you think of explicit teaching, you often think children sat at desks facing the front listening to the teacher. That's not what we mean in this particular instance. What we mean is being explicit that we are teaching a mathematical concept, but that will be done in an age appropriate way. So short and frequent sessions, using a variety of formats. So discussing maths in a storybook, playing and discussing a mathematical game, doing a puzzle, singing a rhyme or a song, all of those would count as explicit teaching of mathematical concept. But it's more about the planning in, this is what we are teaching at the moment, here's the time set aside for it, and these are the activities that we're going to do in order to support that. So I've already mentioned some of those contexts there. Puppet play is an interesting one, and this comes into one of the other recommendations later on as well, actually. What we found in the evidence was that puppet play was particularly important because children were much more likely to identify an error when the puppet made the mistake rather than when they themselves made the mistake. So let's take a simple example, counting from 1 to 10. The child counts from 1 to 10 and misses out number 6 but doesn't notice. the puppet counts from 1 to 10 and misses out number 6, the child does notice that. So that was the rationale really for including that. There's been a number of studies done which suggest that's a particularly powerful strategy to use. I mentioned explicit teaching, but also the discussion that goes around that we found to be particularly important, and I'll come back to discussion in a minute. Critical for getting children to form those more sophisticated mathematical ideas. And one area where we found particularly strong evidence was in the use of games, and in particular games which have numbered squares, or not squares, numbered spaces, which I should say they don't have to be squares, but they have to be numbered in order, and they have to be the same size spaces for each one. So the snakes and ladders board I've put there is a good example of that, although I do have a bit of an issue with that I'll come back to in a moment. But this is the one that's taken from the guidance report directly, this caterpillar game, and you can see they are in order and the circles are all the same size, and we found that to be important. One of the studies that went into this was done, they basically had 2 groups of children playing the same game, but one group had the game with numbered squares and the other group had the same game, but there were no numbers on the squares. And what they found was, as a result of playing that game, the children with the numbered squares had grasped number concepts in a better way than the children who used the plain squares. So that was particularly promising. But again, it's things like the discussion that goes along with that, and planning in when to use particular games to link to the particular objective that you're working on at the time. The other benefit of using games is it's easily transferable to the home environment. So it could be that families already have some games with numbered squares, or it could be that schools could relatively cheaply provide not full board games. Obviously that would cost a fortune, but sort of laminated A4 style board games to be played at home. So that was another reason that this one came out strongly, as it was easily transferable to the home environment. I'll just come back to snakes and ladders, because my issue with this, and this is purely anecdotal from playing this with my 3-year-old, is that the fact that the numbers switch direction is problematic. So 1 to 10 go left to right, and then 11 to 20 go right to left, and that isn't the way a number line works. And so I just have a slight, as a mathematician, I have a slight problem with snakes and ladders, but it does come out in the review. That's just my personal bias, I think. But you might find that causes a slight issue, because I know I certainly did. Just sharing another paper. Now this one is not one we're going to look at this morning, but I would highly recommend, if you have time, to look at this paper. It's really short, but it's great. Clements and Samara, Myths of Early Math. It's American, you can tell from the math spelling there. But one of the things that one of the myths, if you like, that they busted within this paper is one that I've heard, and the argument I've heard is that actually early on we really need to focus on literacy. Mathematics, yes, we will do, but literacy is the most important thing. And this myth, if you like, is that time spent on maths is time taken away from things that are more important. Actually, what they find from the evidence there is that perhaps counterintuitively, children that have access to high quality good mathematics involved with things like moving, building, playing, counting the number of steps as they climb, counting the number of times they hit a balloon in a game, that contributes to literacy just as much as it contributes to mathematics. So actually there is real benefit to literacy in some of this stuff as well as to mathematics. Also in this recommendation is storybooks, or our storybooks I should say, and research shows that these can be really effective. However, it's how we use them that's important. So what we're not saying here is that we should find artificial mathematical situations in a book that we happen to be reading at the time. What we're saying is we should explicitly plan texts based on the mathematics that's contained within them. So thinking, let's say we are working on a particular objective, let's say counting backwards from 10 to 1, because it's an easy one with the one that's on the screen there. So when we're teaching that objective, we should explicitly look for a storybook that features that within the story. So on the launch pad, as you can imagine, with the rocket counting down from 10 to 1, and then we can think about the discussion questions that go along with that. the evidence with this, similar to the evidence with games and also with the evidence around finding mathematics throughout the day, is about the planning. So it's not just doing these things, but it's thinking, OK, here's our objective. These are some games that would really support that objective. Here is a storybook that would really support that objective. These are the questions that would be good to ask to support the mathematics within that storybook. So it's the planning that's important, and that really comes out strongly in the evidence. It's not just about doing these things, it's about really carefully thinking through how it's going to work. I'll share some tools later on that are going to come out from EYFS shortly, hopefully in order to support that. And the last thing before we break off is around this idea of extended discussion about mathematical ideas. So what we found is things like sustained shared thinking and guided interaction work particularly well in mathematics. So really making sure that all practitioners, we use the word practitioners throughout the report to mean anybody that works in any way on mathematics with children, and we chose practitioners because early years and Key Stage 1 we just wanted a sort of catch-all term for anyone that works with those children. So really making sure that practitioners are aware of the kind of question stems and extending discussion kind of questions that would be useful. And there's a few examples there on the screen, but again I'll share a tool later on that's got much more of those in there. Okay. I'm conscious of time, and so oh sorry, I will just mention about mathematical vocabulary. We found within the evidence review that it was really important to reinforce mathematical vocabulary, but also try and reinforce it throughout the day, so not just during the explicit teaching but also as we move throughout the day. And actually that we shouldn't necessarily start with formal vocabulary, so it's fine to use terms like pointy and curved, as long as we progress gradually when the children are ready to more formal vocabulary. Things like correcting the use of big when a child means tall over time becomes appropriate. So that again is something that came out within the review there. So we're going to split off into our breakout rooms, and Laura's going to explain in a moment how this is going to work. I want us to focus initially, please, on pages 12 to 14 in the report. So it's the first part of recommendation 2. There's not a huge amount of writing on pages 12 to 14 because there's a lot of diagrams as well. And I want, as you're reading through that in your little discussion groups, I'd like you to think about the questions that I've put on the screen there. And these will also be in your breakout rooms in the chat there. So first one is, what does purposeful mathematical activity currently look like in your school? Do you set time aside in your school to support teachers in planning? I've put mathematical questions related to storybooks, but it could just as easily be, appropriate games to support current objectives and things like that. Do you use games specifically to support the learning of current objectives? And also thinking about how could we engage parents in this? Because I actually think out of the 5 recommendations, this is the one where parents could probably get involved. Some of the others less so, but this one certainly. And I'll hand over to Laura, who will explain how this is going to work.